things for the future, for today, in fact. And I don't know how to move my. Do you see it? Sorry, I cannot activate my slides. Okay, maybe here. Okay, does it work? Okay, so it's me. So it's what I have done up to now, and okay, sorry. Is it really a problem for you or not? Because I don't know how to remove the second one. It's okay? Okay. So, thank you. My work was first on all what is electric, okay, protection, control, transport and distribution for all sectors. I mean EDF or whatever. And the biggest problem today is that the formal electrical installation is the biggest consumer of copper. I mean that we have an increasing demand everywhere, even for cars and other things like that. And we have a sharp increase in cost. So the sold out is not very far. We have also a very low level of safety. I mean that, for instance, in the USA, you have a lot of fires every day due to the electrical installations. The circuit breaker protects only the wiring and not the loads. And the circuit breakers is never tested. So nothing for your comfort and nothing for your safety. And we have changed it. We have done the volt flow. It's an electrical grid which has been reinvented to become sustainable. It's very important. It means that we have to save copper, for instance. And our solution is a distributed electrical architecture with electronics protection. You have something there to represent it. You have a main primary core and several secondary cores which are connected to the loads. That's the formal star architecture. Everybody knows that. It's at your home, for instance. And you have the length of cables and installations and too much copper, as I said at the beginning. So we have changed it. We have to do that. We have a main cable able to transport the quantity of current that you are authorized to use, and then local power distribution. So you make a gain of up to 85% of copper. The problem, you have visible boxes and no central access to our breakers. So we have made decentralized electronic circuit breakers. Okay, all is electronics, so it's good for that. You can see everything from your screen and so on. But other problem is that the safety is very poor, as we said at the beginning. And so we have done a multi-wire power bus like that. In fact, you have distributed the energy not only by one cable, but by multiple wires. For instance, if you have, I don't know, 32 amps at the beginning, which is authorized, you can have 8 wires of 4 amps, okay? It's safer, and you have better communications. So the secondary breakers are electronics. Okay, so with this very easy ID, very virtuous ID, we have a lot of safety, the safest architecture today, fault and failure tolerant. We are able to program protections for loads. For instance, if you have only 1 amp to distribute to a system, you can protect for 1.5 amps your circuit breaker. All is non-hackable and confidential. Data as communications, and you have a permanent test of the protections. It means that you can test always and permanently your circuit breakers. About the programmation, the user is a friendly user interface. No need to modify the wiring. You can change everything, the function of every switch or whatever. No need to add timers. It's inside. It's programmed. Switching relays. It means that if you have electronic protection, you have also relays. Okay, the same. You can program each load as you need. So you have a full automation. All is inside and very cheap. About the sustainability, you save 65 to 85% of copper gain, and you have a circular economy possible. It's programmable to save energy, money, for instance. If you want to stop your consumption or to be advertised about that, you can do it. You have an automatic compensation for power. And shortages adapted, it's an automatic compensation for power shortages adapted to the user needs. It means that if you need to have less consumption, okay, you can adapt it to your priorities. Okay, it's inside. It's you choose. So it's easier and programmable. Easier to install, of course, because you have a very soft wiring. Auto diagnostic for everything, auto maintenance, planned reparations and tools. So you see, it's really the next system to install at home and everywhere. In fact, even in an aircraft, for instance. So now we have some new patents to deposit, and we need to find people to pass from the demonstrators to the products. And for that, it's more complicated. Okay, we have certifications and so on to pass, and I look for people for that. Another point is about the communications. As you have seen here, with 8 wires, we could add the equivalent of 21 independent PLC, for instance, okay? But we have a biggest project to do with that, with communications. And we have also a need for partners in that case. What we need to is to redesign everything to have a very little box. So maybe a partnership with founders, with people who make components. Okay, it should be very great for us, because at the end, our system will be cheaper than formal architectures. So thank you.